Okay, seems to me that there is no question, so we can have a look to the following topic. So how to use contribution about screen conductors. Well, what are we going to have a look at? First of all, what is a screen conductor in XGSLab? What can be represented with a screen conductor in XGSLab? How does the screen conductors library work? How to set up a system with a screen conductor by drawing, so drawing inside the software. How to set up a system with screen conductors by importing from the XF. How to enter and edit different conductive parts of the same screen conductor, and different ways to set up connections, and also some simple, well, more than it is just one simple example about screen conductor. So basically, what is a screen conductor? You have a screen conductor when the user uses multiple independent conductors in the same position. This is in XGSLab a screen conductor, and it is used. This is the way we use to represent conductors that are typically cables, screen cables, and gas insulated conductors. So in this case, you have gas insulated lines and also gas insulated substations. These are the main applications about the screen conductors. So now we are going to see how, first of all, the screen conductor library works. Okay. So what we are going to do is to have a look, as I said, to the screen conductor library. We have that the screen conductor library is available in GSAFD, in XGSAFD, in professional, standard, and also research licenses. We have that the screen conductor library, you have the chance to set two types of a screen conductor, the pipe type and the stranded type conductors. Let's have a look to the screen, to the pipe type. You have, as the name says, two concentric pipes, the one for the core and the one for the screen. You have different parameters to set up. You have the chance to set up all the materials or the different parameters about the diameters and so on. And you can see also live changing anything. For example, if we change the material, we can see the color that is changing. We can change the diameter, for example. We can change the number of the cores. So, for example, in this case, we can set different cores for and different angles. So, and maybe with a lower diameter, we can also appreciate in a better way the thing that we have different cores. So you can see that you have a very high detail of possibility for setting up the screen conductor. You can also see the legend that shows you the meaning of all these things, all these parameters that we have here. So for example, we can see what is R2, and R2 is this one. We have R1, the diameter of the single conductor of the phase conductor, the internal radius, that is this one, and also all the data about the screen. If we close without applying, we let it as it is. We can have also stranded type screen conductors, for example, like this one. So as you can see, we can also set stranded cores and stranded cores and screen at the same time. And also we can set an insulation. In this case, it is made up of, well, in this case it was, sorry, because I used the scroll wheel. So we have a bitumen, and this is the reason why the color is about something black. So this is about the library. We have the chance to set up to 4 conductive parts in the same screen conductor. And then now we have to have a look at what is how we can set up the screen conductors by drawing it. So we can go here, for example, we can set, for example, cable as a tag that we wanted to use as tag for the new drawing. We can set what the type of conductor that we want to use to screen conductor. We can set to pipe or also stranded, and we can choose the only one that we have in the library. Now we can draw as we know that we can do by using the tools here. Also in this case, I remind you of what I told you before. Is to say that within this year, much likely, this software will undergo a great advancement in the graphical output and the interaction. So these tools maybe will become a bit obsolete, but we will try anyway to keep the way of working homogeneous to this one. So also in the future, you will find something more advanced, but very similar in the way of working. So we can try to draw. So you can see that there is a specific way to represent the screen conductor with some circles all along the screen conductor. And if we draw more than one of them, we can see that we see these black dots. What are these black dots? These black dots are the connections, basically. And if I select all these connections, I repeat this action because I want it is very clear. I drag my mouse containing in the drag and drop the dot, just the dot, and I press enter with my keyboard, and I see all the connections that are selected. We can see that we have all the connections that are there in this selection. And basically what is happening here, when you draw a sequence of screen conductors that are made in the same way, the software automatically connects the same conductive parts. So the screen of the first conductor is connected to the screen of the second. The core 1 of the first is connected to the core 1 of the second, and so on. So this is made automatically by the software. Why? Because you are drawing 2 screen conductors of the same kind, and so it is easy or better, it is reasonable that the software is drawing a complete line with that is connected, obviously. In case you are not drawing all the same sequence, it is not possible to know that it is not possible to know that how the connection are made, or it is not reasonable to suppose, to guess how the connection are made, and so the software let the user to do that. We can see this aspect in importing, while we want to import the system. If we wanted to go in the importation from a DXF file, let's first of all have a look to the file that we want to import. We can have a look very quick. Okay. Okay, sorry, we cannot import. We cannot have a look at it. What we can do is anyway set the importation. So basically, once the importation will be made, we will be able to see it. We have two earthing systems that are connected with a screen conductor. We can set this XGSLab file. Okay. We can open this. So this is what we have just imported. We can color by tag. So we have that the green color is Earth 1. This, let's say brown or red-brown color is Earth 2, and all the rest is the screen conductors. As you can see, we have that the different conductors of the same kind. So all these lines that were in the DXF, a single line, and were in sequence, and all in the layer of the screen conductor, are automatically connected. Why this? Because it is reasonable to think that this is what the users want to have. What is not possible to do is to connect the different two earthing systems to the screen conductor. Why this? Because here we have 4 conductive parts. And so we have to understand how to interact with the screen conductor. Because when we select a simple conductor like this, we select it and we can, by pressing enter, edit it. But when we click on a screen conductor, we have to choose which conductive part we want to use of it. So for example, let's suppose that here we want to select the screen of this, because the screen is earthed in the Earth 1 earthing system. So in this way, I have selected the screen. Let's suppose I select also this conductor of the earthing system. And now I can, with the right button of my mouse, set up a connection. So in this way, we are setting a connection that goes from the starting point that is here of the screen of this cable to the ending point, in this case, of this conductor, and we apply. As you can see now, we have set up this connection. The same thing has to be done in the other end of the screen conductor. So we have to click in order to to select the screen, and we have selected it. Then we have to select one conductor of the external ring of this earthing system that is supposed to be a wind tower or something else like a lattice tower. And in the same way, we can do the connection of the end part of this screen conductor to the starting part of the other conductor. And also in this case, we have realized this connection. So if we run a debug now, since we have set in electrode 1 both the screen and the two earthing system, we find obviously that the only error is the missing we have the missing how to say connect the missing energization. So let's suppose now that the fault there is a fault here that well, or better, there is a fault here in this end of the screen conductor, and the fault is fed from this end. So from this end, let's suppose we want to set an injected current in one of the cores of the screen conductor. So let's suppose we want to choose the core 1 of the screen conductor, and by pressing enter, we want to edit it in order to set an injected current at its starting point of, let's suppose, 10,000 ampere. So as you can see, if I want to edit the different conductive parts, we have to select which one we want. And in this way, we have selected the core 1, and we have selected as faulted. Now we want also, since the fault, we want to realize the fault, so the connection between the screen and so also with the earthing system here, between the screen and the core here. So let's suppose we want, well, not to suppose, but in this way, we want to select both the screen and the core. And once we have selected them, we can use this option, for example, with the right button of the mouse, in order to set at the end of them, in order to set it here, we can apply. And so if we, for example, sorry, not in this way, but if we enlarge the view here, we can also try to select this specific point. Sorry, in this way. Okay. Here we have the connection, but there is also one. Okay. Okay, I'm not able to find it, but it doesn't matter. If we have a look at the table of the connection, we can find that there is also this last connection, that is the connection between the core 1 and the cable and the screen cable. So once we have set up now all the connection in this way and also the injection point, we could expect to be in a debug, in a successful debug, but this is not true. Because we have connected with a connection, the core 1 to the screen, but we have not changed the electrode number of the electrode of the core 1 to electrode 1. It is still electrode 2. So a very easy way to change the electrode belonging of the core 1 is to go to data, to use the tag filter, and let's select just the core 1. Once we have done this, we select all of that, and we change the electrode into electrode 1. So this is the easiest way to do that. Obviously, we can also go to the list and look for the tag, the core one, and so on. And now the debug is going to be successful. We can also run the calculation in this case. So basically, we have that the current, the full current injected in the core is goes to this electrode, and also partially goes back through the screen. So it is very interesting to see what happens also in the distributions. So, for example, we can have a look at the current that goes, first of all, through the cable, the core one, and goes back to the screen. So if we have a look at this, obviously we have this distribution that does not tell you so much, but if we use the consecutive option, we can see this very interesting distribution that basically tells you that you have the injection of the current, you have a quite constant current in the core. Then we have a discontinuity. Why? Because part of the current is injected in the electrode 2, the ring, the foundation of the wind tower or of the lattice tower. And then we have a current that decreases gradually. Why this? Because we have a poor insulation that is made up of bitumen. We have seen previously that the stranded conductor that we have used, this one, has got an external insulation made up of bitumen, so a quite poor insulation. Let's suppose we change it into something different, something better, something more performing like PVC. Obviously, we lose the calculation and we have to run it again. In this case, we will see to analyze the same result we analyzed before. So core one cable screen, we can see two flat values. The first one in the core, the discontinuity due to the connection to the earthing system, and the second, the way back, let's say, to the electrode one, that is here to a lower value. In case we want to, well, maybe in this order it is much more intuitive. So basically, this is what I wanted to show you. Also, in this case, if you wanted to ask questions, there is some minute to do that. If you have no questions, we can get back here. Let's say that, well, I can show you also something about the different ways to handle connections. Let's say that when you handle connections, you have that you can edit them in more than one way, as said, by selecting them directly in this way, as it is, as if it is a conductor, so you can add it directly in this way, or you can select it by dragging your mouse. If you drag your mouse, as said previously, you have the chance to select multiple connections, like in this way. So also with the right button of your mouse, you can enter all of them in this way, and you have more than one connection that is available for modification. When you select more than one connection, you can enter each of them by using the connection editor in this table. Consider that, well, some users already know when you deal with the connections, and especially if you have very long lines made up of screen conductors, it is easy to have a very, very long list of this one, of connection, thousands of connection. So it is very useful to point to a specific connection in this way in order to have a sort of a short list that is much easier to check and to edit. There is one question, just a moment. Is it from Edward? Is it possible? Is it some possibility under consideration in the future to work with a solid bodies like wind tower foundation concrete? Okay. Well, this is not about screen conductor, but let's say that not in the near future. Let's say that in the near future we are, as I said, dealing with a new graphical interface, both with the data input and output. So that is our main goal in the near future. In the very near future, we have some other targets that are already, let's say, reached in some ways, because we have, for example, set up also the possibility to set SPDs, not only transverse impedances, and so on. Any other questions about screen conductors? Consider that the screen conductors, I don't remember if I told you before, but they are available in all the FD. Well, there is one raised hand, just a moment. There is a question from Mr. Reddick. Can you write down in the chat? Okay, please write down the question in the chat box, because otherwise it is quite difficult to handle them. I was just telling you that we are dealing with the development of the SPDs. Okay, there is an additional question. Would the screen conductor be used, for example, to evaluate the transfer potential during a fault condition? Well, I think we have done something of that kind in this way. That is to say that we have connected through a screen conductor two earthing systems. Well, I have to run again this calculation. Just a moment. Okay. And consider that we have this is the potential distribution. Well, let's keep off the tag filter. Consider that the rise of the potential here in this electrode on the left is due to the current that goes back through the screen of the conductor connected to a PV. Well, Yes, for sure. I am referring to the question. To the question of a high voltage substation connecting a photovoltaic plant via OPEW from Northeast Stefan. So it is possible. The question from Mr. Fakari. Is there a overhead line in some parts of the route between two earthing systems and for the rest is buried cable? How can we model this condition? Well, let's say that this model is built in XGSAFD, and in XGSAFD is also possible to model conductors outside the soil, above the soil surface. So consider that it is possible to do in case you need it. Which will be the procedure if we want to calculate the GPD between conductor and the soil potential in one point from Julio Bernabal. GPD, the ground potential distribution. Am I guessing right? Well, let's say that the ground potential distribution is what you can calculate by using the Earth, the area calculation. So in this case, we should go to analysis, area calculation. Let's suppose we want to choose this area, and we can, well, let's keep a bit larger the calculation point. And we can see that the ground potential distribution is this one. I don't know if I have understood the ground potential difference. Well, the soil potential in one point. Well, let's say that the ground potential difference is just a moment, because we have to understand exactly what is this. Because between between conductor and the soil potential in one point is something that is the touch voltage, basically, or something that is linked very closely to the touch voltage. Consider that to do that, we have the possibility to set the reference points. For example, let's suppose this, and let's name it corner. Okay. And if we go back to the area calculation we have just calculated, well, actually we have also to set up some limits. So let's use the very quickly the European standard in order to do that. And then we can enter this section. So we can use the reference point, the reference point corner, and we can see, for example, the prospective touch voltage, and we can do this. So here we have the touch voltage surrounding soil and the cable laid in it. Okay, so we can we have some we had some detail more about this question, and well, let's say that it is true also, like David Lewis is saying, that in case of cable, this potential difference is something very similar to the covering stress voltage. So let's suppose we want to understand what is the potential difference in the between the screen of the screen conductor and the soil, the surrounding soil. We have to go to results, find covering stress voltage, use the cable screen as filtered tag, and here is the distribution.